Mhm. Sometimes, when I remember. More importantly, it's usually archived for like you guys to use when you're reviewing for the midterm. That's my main goal there. But because you're here, I know who you are, which means that you're much more likely to get your participation point.
Yes. Wait, on Monday? Yeah, who's in that Monday? Yes. That's not bad. Wait. It's a clear transfer. Yes. Yes. Right, here's what this guy said. Here's what this guy said on a Sunday meeting. And Sunday meeting, he walks in. He hasn't done any work this semester. Right? He is. We're like doing stuff. We're working on a presentation. He's like, by the way, guys, I'm gonna have to do any work on this project until I get a job. Just so you know. Like, this is a lot of
All right, this chunk of the room over here should remind me of names.
Sean.
So many Seans. How can I keep all the Seans straight? Okay. Say it again. Very good. Jeffrey, I've got that one. I've got that one. I want you to be Kevin, but Kevin's over there. All right, you're Garrett. I should know that. You're in my like IPA 2 Hall of Fame when that's coming up. Good morning. If I lose my voice in the middle of this lecture, I'm tagging in somebody from the front row. So, Mina, be ready. No? Okay. This is the 4th seminar I've given this week. And the one last night was like 3.5 hours. So I'm starting to kind of lose it. But if I start talking about something that has nothing to do with today's topic, you know why. Last night I gave a talk at a conference sort of deal, and I started just like randomly calling on people in the audience. It was both ways. Like, you're screwing me up for them, they're screwing me up for you. So it'll work out just fine. All right. Following up from last week's, Tuesday's lecture on input devices, here is our UI to consider today. My wife sent me this after the lecture, said she thought you guys would like it, so why not? They may be winning for most base in a user interface video so far this semester. So what do you think of that thing? How does it relate to various things that we've talked about thus far in this class? Yeah.
Input devices.
Thank you. I had that part. Indeed. They make a very specific appeal in that pitch that is related to something we've talked about the past couple of weeks. Anybody catch that? Yeah.
Typing by feel.
Yeah, so they talk about how, like, you know, typing on the, you know, typing by feel is a different thing than typing on the screen. Yep.
Trying to minimize the load on the cognitive processor.
Yeah, so they talk very specifically about, in just this one tagline, about how, like, if you're touch typing, you're not thinking about the action of actually, like, inputting the text. Whereas if you are, like, dealing with a soft keyboard, you're using more of your kind of cognitive load to deal with that part of it. So that's fun. Today is all about prototyping, and this is going to be kind of a broad summary of prototyping as a process, as opposed to a very deep dig into one or two specific types of prototyping. We will, over the course of the rest of the semester, catch some of these things in more detail. So Valkyrie Savage is going to come give a talk about sketching from hardware at some point, and probably I'll give some sort of talk at some point about, like, physical device prototyping. We'll have all sorts of good things coming up later in the semester, but this is just kind of the overview. So in one sentence, what is a prototype? Please. Okay, so the fundamental thing is that it's something that helps you get feedback, something that helps you answer questions that you have about your product and head gently in the direction of a final product. Here are a few popular definitions of these things. So prototypes, the means by which designers organically and evolutionarily learn, discover, generate, and refine designs. So it's all about kind of continuous forward progress. A representation of a design made before the final solution exists. This is one of the co-founders of IDEO. Producing early working versions of the future application system and experimenting with them. This one comes from a very software engineering perspective. So they're talking about, like, working systems, things that actually, you know, have some functionality to them. But as we've discussed in this class and as we'll dig into today, not all prototypes need to have kind of functionality or be implemented in software. There are a lot of different ways to approach the problem of, like, getting feedback from users. So the roots of kind of the way that we as user experience designers think about the prototyping process really come from industrial design. Does anybody know what they're prototyping here? Yeah, so what they're actually prototyping is the seat layout and seat design for one of the very first like big jets. One of the first, like, cross-country, long-haul sort of Boeing jets. And this is in the 50s, I'm going to say? Sure, 50s-ish. And the idea here was that they wanted to know more about, they'd never done this. They'd never built a big freaking jet and shoved a bunch of people into it and sent them across the country. And so they needed to get some information about, like, how will this work? Will people be okay? Will people, you know, survive? Will people, you know, be able to sit in these seats for 6 hours without, you know, losing their minds? And so what this guy did, whose name eludes me, but what this guy did is he brought a bunch of people into a warehouse and he built this, like, replica of what they were thinking the big jetliner would look like. and built it in a warehouse, and he literally just made people come in and sit there for like 9 hours at a time and sit in his warehouse for 9 hours, and he saw whether they could handle that, like whether they could, sit in the chair and be comfortable and had enough room to move around and all that sort of thing, so that they didn't have to build an airplane to find out whether like building an airplane was a feasible thing to do at this scale. So very straightforward industrial design sort of process. And the world of industrial design really came about in the 40s and 50s. Why did prototyping happen in the 40s and 50s? What about that era led to the prototyping revolution? Yeah.
Was it that mass production was feasible only in the 40s and 50s, and hence you start off with something, make sure that there are no mistakes in it, and then go ahead and do mass production?
Yeah, I mean, that's the basic idea, is that this is around the time period, not that we didn't have mass production of various things before that, but this is the time period where it started getting pretty serious, where you were moving away from kind of an artisan or a craftsman making individual artifacts and into an artisan or a craftsman making one, and then a million copies of it get made in some sort of industrial process. And so now when you start getting into those sort of quantities of individual things being built, it better be right. You don't want to waste a huge amount of money going out and building these things. So this is a very famous book by Henry Dreyfuss, and I have a little bit of information here. Oh my God, that was terrible. A little bit of information here about that. What is interesting? Yeah, well anyway, so in here, it's basically a step-by-step guide for how you go out and you do industrial design processing. And I know you can't see it here, so I'm not even going to bother walking through this. But basically, the overall flow that he's describing here is very similar to the iterative design process that we've been going through. So there's things like go out and study the competition, and then familiarize ourselves with the manufacturing facilities, learn how the product will be used by real people, go out and talk to the engineers and do sketches for a prototype, build the first prototype, go out, see how people use it, then retool it and go towards mass production. And so this is really the first kind of view of this understand, observe, visualize, evaluate, prototype, evaluate, implement process that we've been talking about over and over again in this class, where you just want to keep going out and learning about what happens with your users when they use your stuff. It's the whole point of this thing. And again, we just keep coming back to this design, prototype, evaluate cycle, which is the key notion of this class. So why bother prototyping? What is the value of doing prototyping work, as opposed to just kind of reasoning about things? And I should mention that that's kind of the difference here. So the past few weeks, we've talked about kind of pure reasoning, modeling approaches to thinking about design. Why is it better to go and just build something and go out and answer your questions? Several reasons. One is that we have a lot of tacit knowledge. We know more than we can tell. The second is that people's actions out in the real world just tell a much broader story than anything that you can do to reason about them. And third is the value of surprise. When you get too heavy into models, it's very easy to think that you're able to predict what people will do and how people will act. And the reality is that no matter how often you do this sort of design work, you're still surprised when you put things in front of a user and you see the horrible things that they do to your prototype. It's very much a process of learning. And so tacit knowledge is this notion that many of us have skills that we don't necessarily know how to tell other people about. So who here thinks of themselves as like a musician? Wow. You're untalented, class? How about like a athlete? Okay. So somebody who thinks of themselves as an athlete, raise your hand. Volunteer to walk us through something? Sure. Give me an athletic endeavor. I don't like that. Give me a different endeavor. Somebody else? Yes.
I play field hockey.
Ooh, I like that. Okay. tell us how to field hockey.
It's like soccer, but you use a stick instead.
Okay, and how do I like goal?
You have a ball and you hit it with the flat side of your stick into the goal.
Okay, and how do I do that hitty bit?
You only use like the bottom part of the stick on the flat side.
Okay, and do I just like whack at it, or do I?
Yeah, kind of like with golf.
Okay, and am I running while I'm doing the hitty thing?
Yeah, but you're crouched down.
And so I'm crouching and I'm crouch golfing, hockey soccer.
While running.
Okay, while running. Excellent. Okay, so now does everybody think they could go field hockey based on that description? Like, would you dominate? No, probably. All right, he's going to dominate. A few of us are naturally gifted and will, just go and dominate the field hockey. But probably you really need to practice these things and you need to work at them. And we would learn much more by watching you field hockey than we can by hearing you tell us about it, is the point of the story here. And people that are really good at things are often the absolute worst at explaining them. It's just kind of how the world works. There's no obvious correlation between skill and ability to explain. And so we want to go out into the world and kind of see how people really work. We want to leverage our own tacit knowledge as designers in building things. And then in that artifact is kind of encoded all the like super secret hidden things that we thought about the design space. And then we can go out and we can actually suss those out and test them instead of just kind of knowing they were up there in your head. So that's the idea of that. A big part of this is that it's really it's hard to imagine how people work in the world without seeing them actually do the things. And so there's this famous study about epistemic action that was watching people play Tetris. And if you were modeling how people play Tetris and you wanted to take a guess at the difference between novices and experts, what's your intuition tell you about the difference in the way novices and experts might play Tetris? Yeah.
Experts are much faster. As soon as they see the block coming, they'll be able to figure out where it needs to go, or they can predict, like look ahead and know which blocks they need for what, like kind of plan ahead.
Okay, so experts can plan ahead. Anything else? Yep.
Continuing with what he said, Tetris you best, I'm guessing, best normal and all country.
True.
Accelerates the whole process.
Right.
So now experts would be able to gauge it better. And
Okay, some of that. If you were to count the total number of button presses, so if you don't know Tetris, like Tetris, your degrees of freedom are like you can move the thing left, you can move the thing right, and you can rotate clockwise or counterclockwise. And then there's also this like drop faster sort of function. If you were to count the total number of button presses between novices and experts playing Tetris, what would you expect the curve to look like? So we have like total input, and we have like novice to expert. What would you expect that curve to look like? Yeah.
I'd expect it to be just like reducing.
Something like this?
Yeah.
So some sort of power law of practice-y looking thing. So that is what our intuition would be from models. Turns out it's absolutely not true. Turns out it's the other way. So it actually looks like this. And the reason for it is that really good Tetris players are like really super twitchy with the rotate buttons. They sit there and they just go back and forth. And it turns out that if you study people's brains while they're playing Tetris, there's a much lower cognitive load of rotating the piece and then seeing how it would visually fit into the space instead of like mentally doing that mapping of if I did this transformation and I put it here, it'll look like this. So when people are playing really fast, where blocks are falling really fast, it actually is much more cognitively feasible to do if you're just constantly looking at all the possible orientations of the piece. So this is the sort of thing that, one, you wouldn't know if you didn't go out and test, because it's kind of contrary to the mental models. And two, it shows the kind of power of having the thing there to physically see. Anybody here a big chess player? Good at chess? Okay, so one of the big challenges for people in chess is kind of visualizing the board, visualizing how things will play out, and sitting there at the board and like imagining the next sequence of moves. It's much easier to play chess if you can, between moves, walk off to another chessboard and like physically move pieces around and like see how it would play out so that you don't lose track of like the continuations of the line that you're playing. And that's another example of this, where like just having the physical artifact there to interact with really changes the way that you think about the possibility space. All right, so the purposes of prototyping, there are lots of kind of models and hierarchies, and there's a popular saying in design that you haven't really done design until you've drawn 4 boxes next to each other and put stuff in them. So there's like 20 of those for different types of ways of organizing prototypes. But basically we want to organize them around what questions do the prototypes answer and when and how should they be constructed. This is one model from one of the famous papers in prototyping. I had you read a different one because I knew I was going to talk about this in class. But they broke down the kind of overall purpose of prototypes into these 3 high-level buckets: understanding existing experience, inquiring actions, and communication. And we're going to dig into each of those right now. So what do I mean by understanding existing experience? This is prototypes that help you in the task analysis process, or that help you in the like sorting out the needs and requirements of your users process. Also sometimes called technology probes. These are just kind of things that help you learn about the world as it exists without necessarily answering any questions about your own design. So an example is when people wanted to design new cell phones, smartphones, for users with limited hand mobility, kind of older or arthritic or any number of other like hand ailments. They made the designers walk around all day using their prototypes wearing like mittens, just to kind of simulate how it feels to interact with the device without kind of the normal dexterity that you're used to in your hands. So this is something that tells you about the world, but not necessarily about your own product, although you could see how it could be both. But in this sense, kind of the gloves themselves are the prototype here, not the phone. Another popular way to do this is a kind of like guided diary exploration of a setting. So here they were prototyping like technology for a train, or the overall like train riding user experience. And so they took all their designers and they sat them down on the train, and then they had a kind of proctor who wandered around the train and handed their people like instructions. So like, right now you are hungry, be hungry and try to find something to eat, just to kind of force people to experience different parts of the overall train user experience. So here, the like cards themselves are the prototype, and this like experimental design is the prototype for helping you learn about how people currently ride the train, that sort of thing. Cool? All right, in the inquiring actions bucket, this is the sort of thing that we usually think of when we think of prototypes. It's like learning about our system and how it could be improved and where we should go with it in the future. And so there's kind of 3 big steps to it: exploring, experimenting, and validating. And IDEO puts this in a slightly different context. So this is their view of, this was from the head director of prototyping at IDEO a few years back, said that over the kind of lifetime of a project, we have, you start with a lot of ideas and you work down towards just a few. And at the beginning of the process, you build prototypes to inspire, like prototypes to explore what's possible in the space and to guide the next stage of your design. In the middle, you do these kind of evolutionary prototypes that are all about how do I improve the product and what could get better and what is getting worse. And then towards the end, you're just trying to go out and like validate the conclusions that you've come to. You know, does our final design that was informed by all these iterations of prototypes really solve the problem in a way that we thought it would? Cool. So here is a very early IDEO digital camera prototype. Talk to me about this thing. What's interesting about this? So this is in the like film camera era when like digital cameras were just like a dream off in the distance. But they wanted to get into the like prototypes of what the UI might look like. Yeah.
It looks nothing like a camera, really.
Okay, it looks nothing like a camera. That's fine. Obviously, the scale is a disaster, and they knew the scale was a disaster. They didn't think digital cameras were going to be that big. Yep.
It has more of like an iPad interface more than a traditional camera.
It does. So they were optimistic at the time about kind of what digital camera UI might look like. Yep.
It doesn't have any words.
Okay. Doesn't have any words. That's interesting. It's true. It's a very visually communicative prototype. Yep.
It has like a large button, which I imagine is the shutter.
Probably. Yeah. That's a knob, and that's a big button, and that's another big button. That I think is a microphone. Some buttons, some buttons. What else is interesting here? Yes.
That white knob like has symbols that you see in actual cameras.
It has what?
Like the symbols on that knob.
Oh yeah, yeah. Yes. So they did correctly anticipate like the sorts of things that you would want to do with the prototype. Yep.
There's no physical viewfinder.
Okay. There's no physical viewfinder, so that seems to come and go in digital cameras. Like, but it's interesting that in this one they didn't do it. Yep.
I'm understanding the picture printed, so it's like the tower is coming from that huge tower in the background.
Yeah. So it's worth noting here that like this thing is actually being driven by this PowerPC thing back here. Like if you want your digital camera, you got to carry your computer with you. You know, so this thing is very much a prototype. Like they didn't know how to build a digital camera. They didn't have the parts. You know, there was no way to go out and assemble this thing, but they know how to build software on a computer, and they know how to take a computer monitor and just shove it up in a piece of plastic. And so you end up with this thing that is being driven by this computer, and these buttons are just kind of being mapped to keystrokes. And then you have to have this like umbilical cord back to, back to the mothership so that you can actually drive your prototype. And so this is a really nice example of like, we're not screwing around with industrial design here. We're not screwing around with like form factor or anything else in that, that bucket. We're just testing the kind of overall user experience of what will it be like to use one of these things. All right, more on the industrial design side. This is the dude who made the first Microsoft mouse. The Microsoft mouse was like the mouse for like 6 years for a while in the a little while back. Anyway, this is just kind of the prototyping process of building a lot of different shapes for what a mouse might look like. And they made like 80 of these things. It's Paul Bradley is the name of this designer. And he made all these things, and they're all made out of foam. And he brought people in, and he had them like try to actually use these foam mice. And it's a huge, huge difference between what you could do in terms of like actually going out and making real injection molded plastic everything mice, which is a, $20,000 per prototype to set up the molds sort of deal, versus just kind of hacking these things together out of foam. So it's all about like quick iterations, rapidly getting things out there, and testing them with users to see how it goes. Who can guess what that is? A prototype for?
Oh, conference.
Okay, it could be a conference phone. It's not, but it could have been. Yeah.
Is it the iPhone?
It is the iPhone. So you've got your like Mac back there, and you've got your screen, and you've got your phone, and you've got your speakers, and I don't know what's going on back here, but it looks cool. Maybe, yeah, I guess so. It's just like a really cool speaker, you're right. And so this is their like first step towards prototyping what the iPhone was going to look like, and what it was going to behave like, and what the overall user experience was going to be. So obviously, like, the actual UI was happening just on a Mac screen with a keyboard and mouse, and the phone bits were just literally a freaking phone sitting there, But this is how you start learning things. Like, if you have no idea what you're going to build, you got to go out and build something. And I think this picture, burn this in your mind and take this with you, because there's this notion out in the world, especially when it comes to Apple, that like devices just magically appear. Like, when Steve was with us, that Steve Jobs would, think of a phone and there it was. And it doesn't work like that. No matter how smart you are, no matter what your design aesthetic is, no matter how good you are at this stuff, it just doesn't work like that. You go out and you build prototypes, and then you take those prototypes and you put them in front of people and you learn about what works and what doesn't work. So on the iPhone 1, the original iPhone, they went through a ton of industrial design work in addition to the actual like UX software work. So here is just quickly a series of their like physical prototype mock-ups for different shapes that the iPhone could have ended up looking like. So there's one, there's one, there's one. That one looks sharp, very pointy. Here's one. That's pretty close, actually. That's kind of close to what it ended up like. This one's got more buttons and more switches, still pretty pointy. That one's wacky. That one looks more like a remote control to me than a phone. Here we've got more buttons and switches. This looks more like the Palm devices. And in fact, I think it is a Palm device, just being wrapped inside like an Apple case here. And then eventually you get towards like what your real industrial design is going to look like. But again, there's no magic here. It's like, have good ideas that are well based in theory and based in your experience, and then try them. See if they work. Go out and then make things. Cool. All right, bucket 3 of why we prototype is to communicate. And by that, I mean both internally and externally. So there's a lot of kind of internal communication within design teams and product houses and companies that are like making actual stuff, where the designers and the engineers and the people that float in between the two and management and sales and biz dev and everybody else needs to be on the same page in terms of kind of what we're building. And a lot of that comes down in our world to prototyping. So you can build a prototype, and it's much better than saying, here's what we're going to do. Because different disciplines kind of speak different languages, it's much more concrete to be able to say, like, this is the thing. We're thinking about something that does this sort of stuff. And then the external communication bit of it, so that's the anchor discussion part, the persuade external communication bit, is that if you go out and you're trying to get funding, you're pitching to your VCs, you're going on Shark Tank, and you want to convince a group of people that like what you're doing and that this thing is a good idea, prototyping is the way to do it. So you go out and you convince people that that you're doing the right thing. An example of this, so this is Lisa, whose last name I always fail to be able to pronounce. Ricklet? Sure. She was the lead designer on the public redesign of Drupal.org. So Drupal still is this big content management system that powers a lot of the websites out in the world. They have a very notoriously hostile community around Drupal, and they were redesigning their webpage. And so they put out in public for the better part of like 6 months all of their ideas. Like, this is what we're thinking it might look like, and this is what we're thinking it might look like. And the point of it was to engage the community that Drupal had and that Drupal had convinced to use their products, to get engaged with what the redesign might look like and provide feedback early, so that when they finally got to the end of the story and they had like a real design, everybody wouldn't be all up in arms. If you remember a couple years ago, the UC system redid its logo, and like everybody got mad, and there was like torches, and I think some buildings were burned down in Oakland. No, that may have been different. But That is where the UC office of the president is, by the way. It's in downtown Oakland, if you don't know that. But anyway, that was the sort of thing where they got that wrong. They just kind of went off and they dreamt up something that they thought was going to be great, and then they put it out there, and hooray, everybody's going to love it. But they didn't do this sort of consensus building where we're going to show you all the different options and we're going to pick one or pick another. And I'm not saying that necessarily they even should have, but it would have been one way to kind of not shock the world when they came out with the logo. You'll notice, did that logo even stay more than like a month? I don't think it, I feel like I haven't seen it anywhere. Yeah, Eeks just redesigned their logo. Who's here even aware of that? Like Eeks unveiled a new logo last week. It was like a yay, new logo sort of thing. But yes, so they do have a new website, and they put the new logo on the new website. It's very fancy. It's more blue than it used to be. That's the takeaway on the new Eeks logo. And it looks slightly less like it was made in the 80s, but only slightly. So anyway, this is one model of what prototypes are for. You read about a different one. Who recalls the purposes of a prototype in the reading that you guys did? There's 3 of them. Yes.
Explore the role, the look and feel, and the implementation.
Yes. So there are these, what do prototypes prototype things? Role, implementation, and look and feel. And basically, role is about context. Role is about like what problem is this actually solving for the user, and what does it do in their life, and why is it important. Look and feel is about the actual mechanics of how the person interacts with it, and where it's going to be, what it's going to look like, and how it's going to do. And then implementation details are all about the actual like engineering behind it. I'm gonna skip those because we're running late. But basically, you end up with these different types of prototypes to fill different problems in your space of thinking about these things. And at the end of the day, here's one more of these like models that people have of how prototypes deal. And you can break functionality up into scope and methods, and you can break scope up into what part of the prototype are you doing. Methods of realization could be low fidelity up to high fidelity, and then simulation and Wizard of Ozzy sort of things. But the point of the story is just that there's lots of different ways to kind of think about the prototyping process. And more than anything, what you should be doing is building something that answers the question that you have. If you have a question about the world, or you have a question about your product, or you have a question about your user, design a prototype experience that specifically targets that question. Don't just build whatever it is you know how to build, and don't just build the most like fancy thing that you can possibly think of. Really think towards the questions that you're trying to answer. Okay? All right, so there's sort of a spectrum here between these like prototypes that probe the world, onto prototypes that answer questions, onto prototypes that communicate. And we're going to walk through a few of those processes. Just understand that like not all prototypes are right for all contexts. So we're going to do paper prototyping next, for instance. Paper prototyping is super, super useful for answering questions. But I wouldn't walk into Shark Tank with it, right? And so just fitting your prototype to what you're trying to accomplish is super important. This is paper prototyping that I did fairly recently for a mobile app we were developing, and went and ran studies just in a cafe for a day. I drank a lot of coffee. I was buzzed for the entire evening. All right, so here is a 1-minute pitch from the Nielsen and Norman group on why you should buy their paper prototyping kits. We'll just watch their ad. That's as far as I'm willing to commit.
This video contains instructions for creating paper prototypes and demonstrations for testing them. We offer tips on the supplies you can use.
Simple widgets can be simulated well with paper. However, simulating complex interactions is a little bit more challenging and not perfect. prototypes that look closer to the final product can provide you with additional data that low-fidelity designs cannot.
This video shows how an application for a mobile device can be tested by using plain white paper.
Paper prototyping is not only for websites and software. This technique can be applied to hardware and three-dimensional interfaces as well.
Paper prototyping is a great way to test your ideas early.
I can't place that accent, but I like it. All right, so paper prototyping, we sent you out into the world with paper prototypes on your individual design assignment 1. And you will note, I'm sure you did note at the time, that I didn't really tell you how to do that. And that was with purpose. I wanted to just kind of see what you would do. So there's the kind of winging it paper prototyping method. And then there's the formal prototyping for tiny fingers, which is a super famous paper that I meant to have the 260A students read. That is all about a very specific method for actually doing this prototyping process. So what do you need to get started? You need office supplies, right? You need paper, you need index card, Post-its, tape, glue, pens, markers, transparencies. And the sort of formalized way that people do these things is that they've learned that the right approach to paper prototyping is to build kind of modules. So you saw in that video where the person pressed the button and then the other person kind of put in a new piece of the user interface. That's really how paper prototyping is typically done. It's a formal process where you make the kind of individual atomic units of your UI. And then on the fly, while you're doing the study, you kind of put together a UI that resembles what your intended overall prototype looks like. And so that can include things like user interface elements. So prototyping actual widgets and icons and text entry and radio buttons and sliders and things like that. Really worth testing at this stage. Yep.
I really love the scrolling thing.
Yeah, that was neat, wasn't it? So they did this, if you caught that in the little promo video there, they had a scrollable window, and they did it by having a big piece of paper hidden behind another piece of paper, and then just sliding up and down the part of it that you could see. And so there's a lot of these things that if you're used to these methods, you can be really super clever about how you construct these paper prototypes and use them towards kind of maximum effect out in the world. So how do you actually go about building it? There is a methodology here. Step 1, as always, is set a deadline. So paper prototyping is supposed to be a low fidelity, super fast way of doing prototyping work. And if you find yourself spending 2 weeks on your paper prototype, you're doing it wrong, because you might as well have just done a high fidelity prototype. So don't think too long, just build something. Draw the context of your thing on a big piece of paper. We usually draw UIs at kind of 2 to 6x scale when we're doing paper prototyping, just because it's easier for the person to actually use. But remember to keep aspect ratios and relative sizes the same. Then you take these different regions of the screen, you put them on cards. You Greek lots of text. Anybody, do you know what that means, Greeking text? Who's a design nerd? Somebody here knows what that means. Yes?
I mean, when you see all the templates for example, when you on Word, you are trying to take a pamphlet or whatever, and you see the same text, it's always just really fancy.
Yeah, so there's 2 different types of Greeking. One, which ironically is actually Latin, is lorem ipsum. So if you've seen this text places that starts lorem ipsum dolores santa me, that is the canonical don't read this text that just says we want to use this to fill some space, and it has kind of the right distribution of word length and spaces and paragraph breaks, and so we'll just fill it in so it kind of looks like text. The other thing that we mean when we say Greeking is sometimes when you see these paper prototypes, there will be blocks of text, and the blocks of text are just that's another method of Greeking, is just having lines that look like they should indicate text but don't actually have any content there. So both of those are Greeking. Balsamic, if you've played with Balsamic, has this feature where if you zoom far enough out, text becomes the wiggly line type of Greeking. It's beautiful. And then you have to be ready for whatever your users are going to do with your interface. So if the user does this button, you have to be ready to slap on this other thing. And then often you will photocopy your paper prototypes so that you can have many versions, and so you won't be so sad when somebody spills coffee on it, that sort of thing. There's this method called Wizard of Oz testing that is a term we abuse a little bit in this class, but we mean it in two different ways. One is just playing the computer, and the other is doing computationally difficult things that you don't really know how to build in software yet, but that you can simulate with a person kind of behind the curtain, hence the Wizard of Oz thing. The canonical example of this is speech recognition. So if you have a software package that's really heavy on speech recognition, you could just have a person there and have them respond to the speech. Back when people thought that total speech recognition was going to be just a year or so away, lots of people built all these elaborate UIs using Wizard of Oz testing, and then realized that the speech recognition technology just wasn't quite catching up at the same rate they thought it was going to. So that's Wizard of Oz. We've talked a little bit about this actual conduct of a test of a paper prototype. But basically you have your user, you have your paper UI, you have your interface elements, you have the person who's playing computer, and then you have other people in the room involved in the execution of the study. And so when you want to conduct the test, you usually bring 3 or 4 people. You have a greeter, who is just the person who welcomes you into the test and says everything's cool here and here's how it's going to work. You have a facilitator who, after the initial greeting, is the only member of your team that actually talks to the person and gives instruction and continuously prompts the user to do the think aloud part of the study. Often in real life, these are the same person. You have the computer, the person who simulates the response. And it's really important that that person not get too interacty with the user, the participant in the study, because they really are trying to just kind of be the UI in some sense. And then you have whoever else is around just taking notes and seeing recommendations. Usually you go about an hour on these things, so 5 minutes of here is what we're doing, and then 40 minutes of actually running the test, and then 15 minutes of debrief. Let's see, what's interesting here. Greeting. This is kind of the first time we've really seriously talked about running user studies, so we'll have a whole Tuesday. Tuesday we'll have a whole lecture on this. But basically, when you run user studies, there's this whole formal process where you come in, you get the person to sign the NDA, you assure them that this video camera over here, or the video we're using, we're only going to use internally, we're not going to post it on YouTube. And then the facilitator explains how the test actually works. And usually on these paper prototype ones, has to do a very simple task. So they'll walk up to the computer and say, all right, so I'm going to press this button and this button, just because this whole paper prototyping thing is weird. And so if you have a user who's not used to that concept, you want to introduce it to them pretty gently. And then more than anything, in every user study, the job of a facilitator is to keep the participant talking. We'll talk a little bit more about this on Tuesday, but there are a lot of different, in principle, methods for running user studies. But the one that we will focus on in this class, because it's the one that I really think solves the most problems, is what's called a think aloud study, where you give the user tasks to do in the user interface, and then you ask them to kind of narrate everything that they're thinking while they're looking at the UI. And so people don't like doing that. It's really unnatural for somebody to say, I'm looking up here in the corner and I see this icon, and I think if I click it, maybe I'll be able to go to this screen. And so now I'm going to click it, and here I go, I'm clicking. But that is exactly what you want from your people while they're doing their user study, because more than anything, what you're looking for in a think aloud study is disagreements between what a user says they're trying to do and what they're actually doing. Because you know what they're actually doing. You know what impact it will have if they actually press that button, but they don't know that. And so you're trying to kind of reconcile those differences. That's the heart of usability. So you observe what happens. You, as the computer and the facilitator, have to avoid biasing the test in various ways. So it's really easy to be like, when somebody like does something that you don't want them to do, or to be, frown at them when they're say they don't like it, or to like sigh and shake your head when they say, sad things about your user interface. But like, you're screwing everything when you do that. So don't do it. Your point here, your reason to exist is to get real data back. And if you are not the sort of person who can avoid being impatient, you are not to do this. Like, don't run these user tests. And if you can't handle somebody being mean to your precious little snowflake of a design, don't be the person that runs the user test. Make sense? More than anything else, don't lead the participants. So let users figure themselves out, figure things out for themselves, and only answer questions if the user gets stuck like forever. And I really mean forever. Like, I've let user study participants go like 20 minutes without making any progress, because that's what I'm there to see. Like, I'm there to see how they correct that problem and what they can do to solve it. And when it gets to the point where they're like, and now I would call tech support, it's like, all right, fine. Like, we'll get you back on track. But believe me, this is hard. This is so, so hard. If you were involved in the design of a product, to sit there and watch somebody hate it is painful. It's not a pleasant experience to have somebody say, like, I can't imagine what they were thinking here, and boy, I hate this part of it. You just have to suck it up and like deal with it. And if you can't, you have to evaluate somebody else's designs and let somebody else evaluate your designs. Really hard, though. Then at the end, you do this debrief where usually you give a questionnaire. I always do interviews. I don't like doing paper surveys at the end of user studies, but some people do like SurveyMonkey, Google Forms sort of things. Ask questions about where you saw problems, gather their impressions, and thank them for their time, of course. We'll go over a lot of this more on Tuesday, but preparing for the test is all about kind of getting the right people. And the main thing I want to emphasize there, again, is like, find the real users and don't just like test on your friends, because seriously, don't do it. Like, what are you hoping to learn about your user interface by showing it to somebody that likes you? Like, that's no fun. Prepare scenarios. So this is going to keep coming up over the course of the semester, where you made this list of tasks for your brainstorming and contextual inquiry assignment. Those aren't going away. So you're going to use those in your paper prototyping process and then in your high fidelity. So if you're thinking about changing your project, think soon, not late. And then practice. Like, running a paper prototype is super hard, and you don't want to be a crappy computer. So you don't want to like artificially introduce bugs into the process just by not knowing how it works. And then understand that Wizard of Oz, like these studies are very different from pre-built or canned functionality. So the computer has to be ready to react on the fly to whatever the user inputs. So a common thing, for instance, is if there's like a text field or a keyboard involved in your paper prototype, to actually have the computer have little strips of paper where they can write the thing that the user just input on the keyboard so that it shows up in the right place on the screen. You have to be kind of very reactive to what's going on in the actual study. Yeah, that's good. Great. Okay, the main thing you're looking for in user studies is critical incidents. So you're looking for the times when people say, God, I hate that. Or you're looking for the times when people say they're doing one thing but actually are doing another. You're looking for the times when it takes them a minute to find the screen they're looking for. When they say, this is awesome. And don't forget those ones, by the way. That was a lesson I learned quickly out in industry, is that if you don't tell the design team what they're doing well, they won't listen to the things that they're doing poorly. So keeping track of like what is good in a user interface is super important also. You use these results to update your task analysis, rethink your design, and just do this iteration process. You can't trust your users to necessarily be right. Like, if they can't find the thing they're looking for, they can't find it. But if they give you like design ideas, that's perhaps a hint at the right answer, but not the right answer, right? So that is that. And always avoid leading questions. Oh, we have too many slides to get through today. All right, administrivia. Yeah.
I just have a question about the doing things right section. For
Yes.
the heuristic evaluation, there was no point where you could say like this was a good thing. I
Right.
was wondering if like that's the point, or like because I felt like if you left that out, like somebody might take out something you thought was really good.
Yeah, it's an interesting issue in heuristic evaluation. So heuristic evaluation really specifically does not get into that. And I think it's mostly because they're trying to be such a discount method that they don't want, somebody sitting around thinking about all the things that are going well when they're supposed to be just moving on with the task. But it is a problem. Heuristic evaluation kind of comes with this notion that like anything I don't explicitly mention is great. And there should be a little bit more gradation there, I think. I agree. Okay, quick feedback on project ideas. So I'm going to send just a couple sentences of comments to every group like tonight. I meant to do this a couple days ago, but it's hard, so sorry. It's not too late to change your concept in small ways on your own. So changing the functionality of your app is something you can do, all the way until the end of the class, just to make it more interesting or better fit the user experience. If you want to completely change user groups, because you're already deep into like the contextual inquiry process, come and talk to the course staff if you want to do that, because you will need to kind of go back out and interview some people from your new user group if you want to completely shift. But anyway, I gave your proposals to several prominent people in like the IoT connected devices space and got feedback. And I summarized this in a post on Piazza, so go there if you haven't seen it. But the big feedback I got from everybody was think about interactivity versus just reading from sensors and visualizing data from sensors. So about a third of the projects that were proposed were read-only, and about a third of the projects that were proposed were write-only, like you're sending things to the connected device, but not doing like any actual interactivity. Think about how you could be more interesting in terms of interactivity. Don't choose just one-time configuration tasks. So a couple of the projects that were proposed were things that might happen like once every 20 years. And while that's interesting, think about more day-to-day, like what happens with your users, sorts of things. And then my boss gave you this advice. The best projects will be those that allow the mobile device to become an active extension of the device they're paired with. And that I think is really correct. Like you want to be as tied to the physical device through the mobile interface as possible, as opposed to it being like, there's this device thing somewhere and then here's a view of it. So come talk to me or come talk to the course staff if you're confused on this stuff. But like really hone in on something that's going to be an interesting demo at the end of the semester. That's your goal here. Important dates coming up. So the contextual inquiry is due tomorrow. True? Yes. Yes, I think. Okay. Low fidelity prototype video is going to be due next Friday. This class just keeps on moving. That assignment's up on the website. It's up on B courses. There's a post about it on Piazza. And I think maybe section next week will be about that topic also. And then the midterm is March 12th. In here, regular course time. See you then. Upcoming material. So next week we're doing usability testing and data analysis. The midterm covers everything up until the end of next week. So usability testing and data analysis are fair game for the midterm. And then you'll notice that after the midterm, this course will kind of shift dramatically in tone. So thus far, we've been doing kind of core concepts in HCI. And then the second half of this course is kind of a topics course. So it's like wacky, fun, interesting things that are the future of like HCI research and new innovations in industry. So look forward to that. The material will get less dry as we get past the midterm, once we're past the kind of core concept stuff. So cool. Oh, we gotta go. All right, prototyping and software. So who went to section yesterday? Did you guys do Balsamic? Wonderful. So I will just kind of briefly go over this. So paper prototyping is cool. There's a movement over the past 5 to 10 years to do kind of low fidelity, quick paper style prototyping in software. And this was actually led by James Landay, who was a professor here at Berkeley when he was here, kind of started up the like software paper prototyping world. He's now at Washington, or did he just leave Washington? I think he's still at Washington. So anyway, a note on fidelity. So fidelity, we're talking about level of detail, like how final does the prototype look, versus just kind of rough sketches with basic functionality. So low fidelity prototyping in software is all about using these sorts of informal design tools, things like Balsamiq that are quick and supposed to be as easy to use as pen and paper. Are they really there? No, but that's the goal, is that they be as quick and easy to use as pen and paper, but with all of the like added benefits that you get from digital design tools. So you can do your paper prototype with like copy and paste and resize and undo and things like that. So that's really the goal behind these things like Balsamiq. And then what a lot of people in the real world actually do is they make their UIs in like Balsamiq, but then they go out and they print them and they actually run their tests still as paper prototypes. Okay. So examples of this, the canonical example was Denim, which was what James Landay worked on while he was here. Balsamiq is big in this space. Prototyping on paper is a iPad app that kind of heads in this direction. But there's dozens of these tools now. It's really kind of blown up over the past 5 years or so. So if you're interested, there's like charts and tables of all the different like prototyping tools and what they're good at and what they're bad at. And you can just go and try some of these things. Then the other side of the like fidelity spectrum in software is high fidelity visual mockups. And so these are things that are usually made in like Photoshop and Illustrator and then brought into something like PowerPoint or Keynote to add the interactivity. So a lot of people do these like fancy things where when you click on a part of the image in the Photoshop comp, it then goes to the appropriate next Photoshop comp. It may or may not be interactive. Making these things interactive is hard, but the interactivity is usually limited to these sort of like preconceived static images, which is very different from the paper prototype where you're supposed to be like generating content on the fly. But it's shiny and it's pretty, and that's good. And if you want feedback on the like shiny, pretty bits of your user interface, doing it with comps is the way to go. The disadvantage to it, though, is that having like super high fidelity prototypes really distorts the perceptions of your participants. And so when things look done, people tend to just comment on the like polish. So if you show somebody a Photoshop comp and ask them for feedback on it, you usually get things like, this font could be slightly less blue, when what you really want is like, I would never use this. And the distance between those two concepts is huge, but it's really hard to get people to say like, I hate this, I would never buy this, when they're looking at something that they feel like somebody put a lot of work into. And then the other problem is designers have the same feeling. So like if the designer team has put a lot of work into making a beautiful comp for every single screen in the entire user interface, they've got a lot of sunk cost, and it gets hard to convince the design team or the engineering team to actually go out and make changes when they're necessary. So I don't usually recommend high fidelity prototyping in comps. It's something that I do not make part of my design process. It's just not a thing I do, but some people do, so we will appreciate them. Like I said, one of the ways that this is done is in PowerPoint or Keynote, where you make interactive portions of different slides, and then when the user clicks on those like active regions, it jumps them to a different slide and they see the different screens. And how you do this without going nuts is you go out and you pay like $6 to somebody on the web that has built like the entire widget library for iOS into Keynote, or has built all the Android widgets, or has built all the Facebook widgets or whatever, so that you have like the bits and pieces to start from and you don't have to build this whole thing from scratch. Balsamiq does the same thing to some extent. They have kind of a widget library that is intended to replicate the sorts of things you usually see on mobile. And then each slide shows one screen. And so now we're getting into this like notion of communication. So I think that the like slideware, high fidelity mockup sorts of things are not good for user tests. Personally, I just don't like them in that context. But what they are good for is showing to marketing, showing to the consultant, showing to a potential client. And so there's this notion in these high fidelity prototypes of telling versus testing. So good demo videos, for instance, are not built in the same way that an artifact that you would take out for user testing is. They tell you way too much about how the interface works and how the interaction is supposed to look like. And they show, you know, I'm going to click this and then this will happen, which is never something that you would show to your user. You would be leading your user and screwing up all your data. But when you're showing it to Mark Cuban on Shark Tank, you want them, you know, to understand that. Can you tell I watch a lot of Shark Tank? I love Shark Tank. It's my favorite. All right, so that's fine. That's good. And anyway, you end up with this like complicated web where you have, if the user clicks here, we jump to this slide. If the user clicks here, we jump to that slide. Back and forth. Everybody get this? We cool? Great. All right, and then the kind of last step is heading towards like fully interactive, high fidelity sort of prototypes. And so these are things that look and behave like the final application, but they take a lot of effort to build. Like it's not a 1 hour with a marker sort of thing anymore. It's a like bunch of engineers writing some code. So there's lots of tools to do this. Like the canonical example is HTML and CSS and JavaScript for building kind of web-based prototypes. JQT is a method for bringing JavaScript libraries onto mobile to do kind of quick prototyping interactions. We are very much in this space at Canoma where we're in the process of like helping people build quick prototypes on Android and iOS. The idea here, and where the like battleground in prototyping is happening right now, is can you make this fast enough that it's worth doing? And can you make the result of this process translate into the final product? That is where the HTML, CSS, JavaScript thing fails most of the time, is that if you did all of your prototyping in HTML and then you're moving to like an actual mobile phone for deployment, it tends to be ugly in that translation. Like if you really tried to make something that looks like an Android app on the web and then you just kind of drop that like Android app HTML thing onto a phone, it's not right. It's not the thing that you were looking for. And so the solution to that problem is you either like build explicitly as an HTML5 sort of app from the get-go and just acknowledge that you're going to be running in a browser on the phone. Or you go with one of these other sorts of solutions that can be used for like making actual deployable production code on mobile. Okay. So just to summarize all this stuff, the advantages of low fidelity prototyping are primarily that it's fast. You don't need special equipment. You don't need special engineering talent. You can really rapidly whip through various ideas. The faster you iterate through them, the better your final product is going to be. You can change the design literally as you test, like in the middle of a user study. You can adapt your prototype. And it's very useful for hard to implement features. So for things like speech recognition and handwriting recognition, and say you're building the software that's going to control a satellite and you don't have a satellite, you know, these are the sorts of things that you almost have to do in a low fidelity sort of way. The drawbacks are that you have to kind of keep drawing. Like while each iteration is fast, it can get rather tiresome rather quickly to crank out these faster than like actually having to recode a UI. Eventually, you have to make the jump over to software. Like if you are in the software development business, at some point you have to go from your paper prototype to software. And then the actual like real-time interactions are a little fuzzy. So, you know, you have to really be able to convince your users that they should interact with this thing as if it were a computer and not like a person sitting there moving pieces of paper around. All right, one last thing. I'm going to talk about video prototyping because your assignment that's due next Friday is a video prototype. So your assignment for next Friday is that you have to go out, you have to build a paper prototype. There's no user testing or anything at this stage. That's the next assignment. But this one is all just about coming up with your tasks and scenarios, building a low fidelity, either literally paper or balsamic or Illustrator or whatever you can do that will help you knock out something quickly, and then doing a video prototype of it. Yep.
Is there going to be a major assignment for the midterm?
No. No. Yeah, it doesn't quite work out that way. So you'll have a little time around the midterm, and then over spring break, you'll have the like high fidelity prototyping assignment, but that's like 3 weeks or something with spring break in the middle, I think. Ask Andrew and Peggy for more details. They're managing the calendar. So anyway, video prototyping. That's good. I can feel this class catching up with you guys, which makes me feel better about trying to scare you at the beginning of the semester. So video prototyping is all about getting everything you know about your users and everything you know about the tasks and the scenarios down in a format that can really quickly be viewed. So if you remember our storyboarding lecture from the beginning of the semester, where it was all about like, you show the context and then you show the app and then you show like individual screens in the app and then you come back out to the context. Same deal. You're basically just shooting videos of that to demonstrate how your user interface kind of fits into the world. And fundamentally, you shoot video of like the scenario and then still images of each kind of frame of your low fidelity prototype and show how the person would interact with it and what the expected outcomes would be. And then explain like why the world is a better place because they used your thing. So I'm going to show you a couple of examples. The first one is from Thingam. It's a group of just a couple very, very prominent designers who are in the business of sketching solutions to exciting new problems. And so here is one example. This one is not narrated, and I will note that yours actually has to be. So how much did they actually have to build to make that video prototype? What did they actually have to implement? Yeah.
Screens for the device thing, like return tags and maybe like you could also pick that.
Yeah, so they had to make like 4 static images for the screens of the mobile app. They had to go and find like 3 RFID tags, which knowing Mike, I'm certain he had just kicking around his house. And then they had to maybe put some lights behind those wine bottles and like manually turn them on and off, or maybe they just did that in post. But point is, that really concisely conveys a product concept, right? Like you could imagine going out and building that. You can imagine where it would sit in Bed Bath & Beyond. You can imagine purchasing it and putting it into your house. Very, very little work actually went into the implementation, though. So that's a very concise, nice tool for communicating a design. Here is an actual CS160 video from spring of 10. And this is very much like what you guys will be building.
This is Mr. Dugan, a middle school math teacher. While he means well, Mr. Dugan can never seem to catch a break. His numerous students and classes cause him far too much frustration. He is looking for a simple way to track his students' attendance and behavior, all while in class.
I'm late to class, I have to take attendance, the students are going crazy, what am I going to do?
This is a job for work.
Now I can take attendance and record behavior.
Well, Mr. Dugan, your roster isn't in the iPhone application. Don't worry, I'll just sync it.
Mr. Dugan simply clicks the Sync tab, selects his class, and taps Important File. Roll call takes a URL and does the rest.
Okay, let's take attendance. Mark Delmeco, Julian is absent.
To take attendance, Mr. Dugan simply taps the names of each student who is not here.
Who are you?
I'm Jordan.
Oh, a new student. Let me add you to my class.
To add a new student is Geometry class and clicks Add Students. Since Jordan is new, Mr. Dugan clicks the plus button to create Jordan's profile. Jordan is then automatically added to the class.
You're doing a great job. I'm going to give you a point.
A student's daily point value is accessed via the blue arrow.
Hey, you! Go drinking in class. You're losing the point.
Daily notes can also be accessed in this same menu.
Class dismissed.
Mr. Dugan, talking about testing the other day, and I was here.
Oh, sorry, Timothy. Let me check your records.
In the Students tab, Mr. Dugan has access to a full student's history.
Oh, looks like you were here. Sorry, let me change that for you.
Mr. Dugan simply selects that date, clicks Absent on the bottom of the screen, and changes the value.
Good. Today would have been a disaster without roll call.
I couldn't agree more.
So that's a particularly good video prototype. We understand that the time constraints in this class are such that it will be a challenge to produce amazing things, but it doesn't take that much to bust out a basic paper prototype, do some stop motion video of it, and get something useful for your final video prototype. So the GSIs will have lots of advice for you on how that whole process should go down. I'm sure they'll post some things in Piazza about tools, and then you can also talk to them in section and in person. Yes?
Because we don't have the connected device, how are we going to show the interactions between the app and the connected device?
Well, so it's another one of these just kind of fake it things where, for instance, they didn't really have a connected wine rack in that first thing, but they came up with an elegant kind of solution for faking it. I would expect that in many of your cases, the solution will be less elegant, but still some notion of what the device would be doing in response to your actions would be very helpful. Other questions? All right, so the pace of this class, as you've noticed, is picking up. Feel free to reach out to the GSIs for help when you need to kind of focus your group and rally everybody's attention. They're there to kind of help you with the team dynamics aspects of this course in addition to everything else. We will pretty soon be doing our first kind of batch of surveys and group evaluations, peer evaluations, to hear how things are going in each group and who the one guy on your group is that you all really hate and those sorts of cool things. So that's coming soon. Any other questions? All right, so next week is all testing and quant and analytics, and look forward to that. I'll get out the readings for next week tonight.
For the video, you only wanted the features from that, right?
Sorry, give me 1 second. Let me kill the video.
Oh, okay. Sorry.